Mine Mover Natsumi, kasama ka ding scientist sa the Mine Museum sa Taguig. So inimbitahan kami dito ng Ayala Malls to do a science show as part of the program, Redraw Your Summer, Imagine Your World. So yung gagawin natin ng mga experiments ngayon are really cool. Sobrang cool kasi malamig talaga siya. At simulan na natin. Hahabol na lang yung iba. Okay, so our show for today is called Frozen Science Show. It's about something really cold. What are the things that you know of are cold? So right now, the temperature outside is around 30 degrees Celsius. And here in the mall, it's around 21 degrees Celsius because of the aircon, right? So the lower the number, the colder it is. How cold do you think is ice? Gano'ng kababa yung number? Yes? 0, that's right. It's so cold that the number is down to 0. 0 degrees Celsius. But what we're gonna experiment on today is colder than ice. Mas malamig pa kasi. That's why I'm gonna use these very special gloves. So hindi ito basta-bastang gloves. These are very special gloves called cryo gloves that I'm gonna use to handle the very first thing that we're gonna experiment on. So let me take it out of its special container and show to you the first cold thing that we have. Alright, what does it look like, this very cold thing that I just put in front of you? It looks like ice. That is correct. It looks like ice because it is a kind of ice. It is very cold, sobrang lamig. But this is way colder than normal ice. It is called, it's a very special name, but I'd like you to observe first what's strange with this ice. Ano yung kakaiba sa kanya? Ano yung nangyayari sa normal na ice, something that normal ice does, but this does not do? Ano yun? It stays what?
Dry.
It stays dry, which is why we call this
Dry ice.
dry ice. That is correct. It does not melt. Melting is what? It's going from solid to when you melt, you go from solid to liquid. But this one, dry ice, it does not melt, kaya it stays dry. It goes from solid to what? We'll see. So my first experiment, so there you go. So my normal ice, this one, and then we have dry ice. Dry ice is very cold. It's way colder than normal ice. So if normal ice is 0 degrees Celsius, dry ice is way colder than that. So yung mga temperature na mas mababa pa sa 0, they're called sub-zero. Kasi mas mababa sa 0. They have this minus sign in front of them. They're what we call negative numbers. So yung temperature nito, negative. Ganun siya kalamig. Mas mababa sa 0. Negative 78.5 degrees Celsius. And instead of melting, going from solid to liquid, it goes from solid to gas. Now we'll see how that works when we have a spoon. So meron ako ditong spoon. Mainit-init na spoon. Nilagay ko sa mainit na tubig parang sa restaurant lang. Gusto ko mainit siya because I want to touch it to this very cold ice. And then we'll see what happens. Now the hotter kasi the spoon is, the better it will be. So this will create a sound. So if you're sensitive to shrieking sounds, cover your ears na lang. Okay? If you're sensitive to shrieking sounds. I'll hold this next to the ice. Okay, that's the sound. So let me try it with my microphone para mas marinig niyo. Try ko sa microphone. Para mas marinig niyo, ha? Let me try another. Here, that's one lap. So ang nangyari, when I touch the spoon next to the dry ice, what does the dry ice do? Ano ulit ang nangyari sa dry ice? Yes? That's right, it's the spoon screams because the dry ice goes from solid to gas. That's correct. It does not melt, no? It goes from solid to gas. That's what we call sublimation. Yun yung tawag sa process na yun, from solid to gas. What is it called again?
Sublimation.
sublimation, that's right, sublimation.
It's from
So
solid,
when I hold the
solid
spoon
to gas.
next to the dry ice,
Sublimation.
the gas makes the spoon vibrate. And that vibration, yung sobrang bilis na vibration yun, that is what creates the shrieking sound that we hear. So let me do that one last time, and again, warning to those who are sensitive to high-pitched noises. Ingay, mas may ingay ata siyang drink kesa sa kanina. There, one last time. And again, that's all because of the sublimation, the turning of the dry ice from solid to gas. What type of gas does dry ice turn into? So can you please take a deep breath for me? Inhale tayo. Inhale.
Inhale.
And then exhale. Okay. So when you inhale, what gas did you breathe in? Anong gas yung nilanghap ninyo? Yes? We breathe in air. And what in the air? We breathe in oxygen. So yung air, ito yung gas, mixture of gases sa paligid natin. When we inhale, we breathe in the oxygen from it. Now when you exhale, anong gas naman yung nilabas ninyo? Anong gas? The gas is? Yes, carbon dioxide. That is correct. So what do you think is dry ice made of? Gawa kaya siya sa oxygen o gawa siya sa carbon dioxide? Gawa actually siya sa carbon dioxide. Okay, para makita na gawa nga siya sa carbon dioxide, same as the gas we breathe out when we exhale, let me do my next experiment. So for my next experiment, I'm going to do, sige, before I go to my next experiment, another thing that we could show about dry ice being very cold. So I will ask for the help of my fellow scientist here. Maneuver nat, we'll light up a candle. So hindi tayo ng isang kandila. Before we move on to my second experiment, let's go to my actual second experiment. So I have here with me a piece of paper. What does it say? Ano yung nakasabi sa paper? Ano yung nakasabi? Yes? It says hi. It says hi. Now what I'm going to do is, sige, tulog po ako sa ating ng cameraman. Kahit isa lang. Yan, ilapit natin yung nakasinding mga kandila. Ilapit natin sa mga kandila. So huwag nitong gawing experiment sa bahay. No? Kasi delikado. Patulong kayo sa mga nakatatanda at sila yung pagawin ninyo. So this experiment involves fire. So be very, very careful. Don't do it on your own. Look at what happens to the hive. Anong nangyari? Does it stay there? Or did it disappear? It disappeared. Is that magic? Is that magic?
Disappear?
Is it magic? No. It is what? It's science. And here, it's working because of the science of the kind of ink we used. The kind of ink we used for this are these. No? What are these? Who's familiar with this kind of pen? Yes. What kind of pen is this called? It's called a friction pen. No? It's the kind of pen na pwede mong i-erase. Pwedeng ibura. Pwedeng burahin, right? You have an eraser here. But it works because when you rub the eraser on the piece of paper, it creates something. So can you please rub your hands together? Rub your hands. Rub your hands, yeah. What does it feel? Does it feel cold or warm when you rub your hands? It feels warm, that's correct. So this pen is able to erase the ink because of friction. Friction, or rubbing things together, creates warmth. So when you have a warm thing like the candle, it's able to erase the ink. Kaya nabubura. So warm temperatures is able to erase the ink. What if we put it against something very cold, like our dry ice? So let me now hold it close to the dry ice. Lapit natin siya sa dry ice. So, tabi natin siya sa dry ice. Ano ulit yung dry ice? Mainit, malamig? Cold, right? It's very, very cold. Now let me hold it close to my big piece of paper. And look at, yan, bumabalik, no? Right? Can you see the piece of paper here? On the, let's start with the leftmost one. What can you see now? What happened to the ink? It It returns, it's appearing again. Again, this ink, this special ink that we use, it disappears when it's warm. And it returns when it's cold. That tells you that dry ice is very cold. Malamig yung dry ice. So it might take a while to make the whole high appear. So let me just make the letter I appear. And then we'll move on to our next experiment. So yeah, if you hold it there, sige, hold it to, lagay ko muna siya para lumamig siya. Okay, and then let me do my experiment here on the side. Okay na. Okay, so for a second experiment, we mentioned earlier that dry ice is made of what? It's made of carbon dioxide. That's right. For our next experiment, we're going to show that it is indeed made of carbon dioxide. So I have here with me a nice solution. Right? What's the color? Ano yung kulay niya? Walang kulay. That's right. Clear. Wala siyang kulay. It's colorless. Next, what I will do is I'm gonna add this special chemical. Yung special chemical na to, tawag sa kanya, indicator. Because it indicates, sinasabi niya sa akin, if my liquid is an acid or a base. Acids, they are things that are sour. Ano yung alam yung sour, yung acid? Yes. That's right. So vinegar is one, right? Vinegar is acidic. It's an acid. And also lemons. That's correct. Lemons, lime, calamansi, they are acidic. They have acids in them. That's why they're sour. So in the case of lemon, it's citric acid. Vitamin C is also sour. Kaya mga vitamin C tablets may acid ng konti, di ba? Because they contain vitamin C, which is ascorbic acid. It's an acid, yung mga ma-acid. And then other things are bitter, mapapait at madulas. Those are base. Yun yung mga bases naman, like the caffeine in coffee. It's basic. Now, okay. Now let's see if this solution is an acid or a base. Let me add my indicator and let's see if there will be a change in color. Nantayin nyo na mabuti. Kung magbabago ba yung kulay. Nagbago ba ang kulay? Did it change in color? No, it did not change in color. That tells me that my solution, this liquid, is an acid. It did not change in color. This time I will add this powder. What's the color of the powder? What's the color of the powder? White. If I add this white powder to my liquid, what will be the color? Anong magiging kulay? When I add this white powder to my liquid, the color will be? White is a good guess, right? Because if you add white powder on liquid, of course it'll turn white. But this time, it turns into some other color. It turns into what color?
Wow!
Pink, right?
Boom! It
Kind
turned
of pink, purplish pink. Alright, so naging pink yung kulay ng ating liquid. This tells us that our white powder is a base, not an acid. Now what I'm gonna do next is I'm gonna blow some bubbles using this straw into my container. So I'm gonna blow some bubbles. So I'm gonna take off my mask. I'm a safe distance from you, so it should be no worry. I'm gonna blow maybe in this general direction. So now in your direction. I'm gonna take off my mask safely and carefully in the correct way. By the way, the correct way to take off your mask is to the side. Diba? Dapat sa gilid, like that. Huwag niyong ibaba, kasi pag binaba niyo, yung germs from your chin will go to your mask. Right? Never do that. That just makes the mask dirtier. Instead, whenever you take off your mask, put it to the side. The way doctors and nurses do it. Okay, now let me blow some bubbles into my solution. By the way, what are the bubbles made of? It's made of a gas. What gas? Again, what gas do you exhale when you breathe out? Inhale. What gas do you inhale? So what gas do you exhale? So what gas am I bubbling into my solution? What gas am I blowing? Carbon dioxide. But what is the carbon dioxide doing to the solution? Is it still pink?
Namuti.
Kaya naging white.
It turned white again?
It is turning clear again. What does that tell us? Sorry. When you mix carbon dioxide with water, it turns it into an acid. Very good. Very smart and fast thinking. That is correct. So again, what is the color when it's an acid? It's colorless or clear. What was the color when it was a base? Pink, that's correct. So what did mixing carbon dioxide into my solution do? Into my liquid? It turned it into... Okay, now let me do that again. But this time, I won't blow my bubbles. Instead, let me put some of my powder. What will it turn to again? It will turn pink. Why will it turn pink? Because it will become a base. That is correct. So this white powder is in fact a base. That's why it turned pink. Now let me put some of my dry ice into my container. Let's see what will happen. Okay, so let me put some dry ice. And notice, pag naglagay ka ng dry ice sa water, you create what? You create bubbles. May bubbles, di ba? Aside from the bubbles that are bubbling. Alright, and that's because the dry ice turns from solid to gas. It does not melt, but it turns from solid to gas. And what did the gas do to my liquid? Did it change the color or is the color the same? It changed the color from what? From pink to clear. What does that tell us about the gas that dry ice creates? What gas is it? Is it oxygen or carbon dioxide? It's what? Oxygen or carbon dioxide? Carbon dioxide. Just like the gas I was bubbling when I was using the straw kanina, right? So it also turns my solution into an acid, right? Because whenever you mix carbon dioxide with liquids, it turns them acidic. In fact, some of the drinks we drink have carbon dioxide in them. Who here knows of a drink? Sino yung may alam dito na inumin na may carbon dioxide? Ano yung alam niyong inumin na may carbon dioxide? Yes! Yes! Carbonated drinks kasi may carbon dioxide sila. Right? At ito yun. Gawa siya sa carbon dioxide. Okay. Now, here's another amazing thing that you could do using dry ice because it's made of carbon dioxide. So yan, time na magsindi ako ng mga kandila. Yung mga fanat, sindi tayo ng kandila, 3 kandila. Sino dito may birthday? Or upcoming na birthday, para ang birthday candles nila rin. Okay, so gagawin natin, nalagay ako dito ng water. And put some more dry ice. What you get? You get bubbles, that's correct. It turns into a gas, and the gas you can see as bubbles. I'm going to use my special gloves. And let's put some. Okay. What gas is it turning into again? It's turning into what kind of gas? Carbon dioxide. Okay. Here's a cool thing you can do with carbon dioxide. No? So fires, in order to keep on burning, they actually need oxygen. So, when it runs out of oxygen, pag wala na oxygen sa palibot ng fire, mamamatay yung apoy, right? It will snuff out the fire. So, with this carbon dioxide, let's see what I can do. Did I spill some liquid? May natapon ba akong tubig? No. What am I spilling? Ano yung natatapon? I'm spilling a gas. What gas is it again? Very good, it's carbon dioxide. So we here see that carbon dioxide can serve as a fire extinguisher. As a matter of fact, certain kinds of fire extinguishers are made of carbon dioxide. Lalo na yung mga green, di ba yung iba sa kanila pula, red yung color. But some of them are green. The green ones have carbon dioxide in them. Okay, let's do that one last time. So here, I have carbon dioxide, and if I spill out the carbon dioxide, it's able to snuff out the fire. What else can you say about the carbon dioxide? Does it float up like smoke or does it sink down? Lumulutang ba siya pataas or lumulubog pababa? It sinks down. That tells us that this carbon dioxide is heavier than air. Mas mabigat siya kaysa sa hangin. Kaya imbis na lumutang siya pataas, lumulubog siya pababa. It sinks down, right? It does not float up. And because of that, we can make all sorts of fun things with dry ice. So, we can we're done with the candles. Put the candles to the side. And then, make something really cool here. I'll put a large chunk of dry ice. Makain ko na. Kasi madami yung gusto ko yun. Malaki na. And then, what I'll do next is I'll wet my hands with soap. Okay, so with soap. Still the best way to disinfect your hands, by the way. Nothing can beat it. And then I put the soap over my glass and I watch my bubble expand. It almost looks like a what? It looks like it's a bubble, and this bubble looks like a crystal ball. But this crystal ball, when it bursts, do you want me to burst it? Gusto niyo bang papatukin ko? Yes? No? Yes? Okay, we'll try. We'll see what happens. If the smoke, no. If the smoke will rise up, or will it sink down? Who says the smoke will go up? Will rise? I did not need to burst it. It burst on its own because it got too big. So as you can see, the bubble is not floating. Hindi siya lumulutang. Because again, carbon dioxide is lighter than air or heavier than air? Lighter or heavier? It's heavier than air. Mas mabigat siya kaysa sa hangin. Yan. At dahil mas mabigat siya kaysa sa hangin, hindi siya lumulutang. Right? It does not float up, rather it just stays there, being all pretty and colorful and amazing and magical looking. But really, it's just a bubble of carbon dioxide. The same gas we breathe out whenever we exhale. Now, mind over not will we'll have fun. There's another way you can have fun with these bubbles, which are again heavy. So yan, ilagay tayo dito ng dry ice, dito naman, right? So dito siya tatakas yung dry ice, dito siya tatakas sa tube. I'll put my dry ice, maybe a small chunk like this. There you go. Maybe a few more.
Oh.
Okay, and then takpan ko siya so that my carbon dioxide is forced to escape to the side. What I'll do next is I'll put some liquid detergent here in my water, and Nat and I are gonna make some bubbles. And these are not your ordinary bubbles. Because again, these bubbles will be lighter or heavier than air.
Wow!
Lighter or heavier than air?
It looks like an egg, Daddy.
Heavier than air. And because it's heavier than air, it does not float. And because of that, it would make it bounce. Let's make it bounce. Make it bounce. There we go.
Like
so
an
you can
egg.
make it bounce on film. Diba? Unlike most normal bubbles, which eventually sink. Eventually nagsisink din yung mga bubbles because the film around the bubble is heavy, but they sink slowly because they're made of normal air. But this one is made of a gas that's heavier than air, which is why it tends to sink. Let's make some more bubbles. Okay. Oops. Alright. So yan. Nakadalawa. Yan. Antayin mo na. Let's try kung Yan. Gusto niya mas mabilisan. Ayun. Ganda na yan. And then you can make the bubbles bounce on them. Okay, so we'll just continue to make our nice bubbles here to the side. Okay? And then we'll move on to our last experiment using dry ice. Okay? And then we'll move on to something even colder than dry ice. So you think dry ice is really cool? Well, there's something even cooler than dry ice. Something colder. But first, we'll go to our last experiment. Okay. So our last experiment, we will use our dry ice to launch a rocket.
Rocket.
Alright, so we have here a rocket. What is the rocket made of? It's made of a bottle, right? And then, what can you see in the rocket? What's the shape of a rocket? You have your what? You have your fins or your wings to make your rocket stable. Or hindi siya pupunta sa inyo. Right? Dito ba? Right? So that it flies through. It flies straight. And then it also has a what on the top? It has a cone-shaped hat. It's called the nose cone of your rocket. To again make it cut through air. Make it fly through. Now what I'm going to do is I'm going to put some water in my bottle. Dito ng water. And then I'm going to put dry ice. Again, what happens when you mix dry ice with water? What happens? You get bubbles. Very good. Bubbles of carbon dioxide. So will the bubbles stay inside my bottle or will it try to escape? It'll try to escape. Susubukan yung tumakas, di ba? Tatakas yan kasi yung gas, the carbon dioxide that you make, will be bigger, will occupy a larger space compared to the ice, right? It'll be the same mass, hindi siya mas mabigat or mas magaan. It'll have the same mass kasi same amount of thing siya. But because it's gas, it's a property of gases that they will occupy more space. So it'll try to expand. And because of that expansion, yan, magta-try siyang tumakas. In fact, I can show that. We'll put another bubble here. Yun na. Try niyang tumakas. Try to escape, as you can see. Ang bilis niya. It'll try to escape, and that's why it's bursting the bubble real fast, right? That's all the carbon dioxide trying to escape. And eventually, there'll be so many of them that the bubble can't hold it anymore. The bubble will burst. This time, instead of stopping it with a bubble, I will stop it with this stopper, a cork stopper. So I'll put it here. Okay, so where will I need you alpha to keep your distance. Layo ka alpha. This will launch up. This will fly up. So layo ka, keep your distance. Stand up. Here you go. For your safety. Okay, so what will the gas do? Will it stay in the bottle or will it try to escape? Tatakas ba yung gas or magsistay doon sa loob? So it will try to escape down. Try nang bumaba, no? And whenever there's a force that goes down, that's what we call an action. And for every action, there's an equal and opposite reaction. Let's see what the reaction of this rocket will be. Can you please give me a countdown? 3, I'll say 5, let's do it 5. 5, 4, 3, 2, 1, lift off!
What happened?
So we have an action and then we have a reaction. That's your reaction, but the reaction of the rocket is it flies up. But whenever we have an action, gas going down, you have an equal, just as strong, but opposite in the other direction, reaction, right? Equal and opposite reaction, so a rocket flies up. Lilipad siya, patas. Who wants to see the rocket launch again? We'll try to do it one more time. Okay. What do you think will make our rockets fly higher? Paano siyang maging mas mataas pa? More ano? More dry. Sige, let's try more dry ice. More water, you think? More water? Sige, try din natin more water. So in science, this is what we call unexpected countdown this time. Okay, what's happening here again? There's action and what? Reaction. What's the action? It's the gas going down. What's the reaction? It's the rocket going. It's the rocket going up, right? Action, reaction. It's trying to fly already. Okay, give me a countdown. 3, 2, 1. Sorry, the water has already escaped. One last time. I took too long. Because, as you saw, our rocket can blast off fire. as the audience requested, more dry ice. This time, give me a countdown now. Let's start from 10. 10. Thank you very much. Maybe it's because it's dry ice over. Is dry ice the coldest thing there is? Dry ice ba yung pinakamalamig? Actually, hindi, no? Again, as I promised, meron pong mas malamig sa dry ice. At yun yung kasunod nating pag-experiment. Okay. So, ask my fellow scientist, Nat, to get that colder thing. Ayan, we put it in a thermos dito sa likod. Ayan. Salamat na. Tignan natin kung ano yung sobrang lamig. Ito sobrang lamig. Ayan, pakita ni Nat yung slides. We'll show the slides, please. Degrees Celsius, negative 78.5 degrees Celsius. Our liquid nitrogen is way colder than that. That's why I really have to use gloves even more so. It's negative 196 degrees. Really, really way below the temperature of ice, which is 0. We'll show the camera. Okay, pakita natin yung camera yung itsura ng ating dry ice. Pero hindi nyo kailangang lumapit para makita ng malapitan yung dry ice. Ano yung kulay ng liquid nitrogen? What is the color of liquid nitrogen? Colorless, that's correct. It's clear. There you go. It's clear and colorless. Just like water. But again, it's not water. It's way, way colder than water. It's liquid nitrogen. And if you can see it in the camera, it's also boiling. Kumukulo siya. Ayan, you can see the bubbles. Because the temperature in this area is too hot for liquid nitrogen. Okay? Because again, this is very, very, very cold. Negative 196 degrees Celsius. So this temperature that we're feeling right now, it's already way too hot for liquid nitrogen. Masyado nang mainit yung para sa kanya. Kaya kumukulo siya. Ayan no, it's boiling. It's sizzling. You can even hear a sizzle when you're near it. Ganun siya ka, lamig. Sobrang lamig niya. Right? That is liquid nitrogen. Nitrogen is actually something we see everywhere. We have every year. It surrounds us. Most of the air around us is made of nitrogen. Alam niyo ba yan? Diba, whenever we inhale, we breathe in. Ano yung ulit yung nilalangap natin when we inhale? Natin, nitrogen. Pero dito, yung nitrogen, gas pa rin ba siya? Gas ba yung nitrogen na ba? Hindi. Ano siya?
Liquid.
Liquid. Kaya tawag sa kanya liquid nitrogen. Now, tignan natin yung epekto ng liquid nitrogen na yun sa mga bulaklak. So, nagdala kami ng bulaklak. We brought some flowers from our garden in the museum. And like all flowers, when I drop it, you know, it bounces. And if I try to squish it, here, try to squish it, it bounces back, like flowers do. This time, I'll put the flowers in liquid nitrogen. Yan. Parang cooking show lang ito. Kumukulo, di ba? Get here. Nagdagan natin ng liquid nitrogen. So this is what will happen to your flowers when you put them in liquid nitrogen. So compare to your original flower. Well, that's our original flower. Now let's get our flowers put in liquid nitrogen out. And then, we'll see what happens if I drop it. Ano nangyari sa kanya? You could see that it breaks. Right? It breaks like what? It breaks like it's made of ice. Because in fact, it has become made of ice now. It is frozen. So let me try to, this is the original flower. That's what happens to the original flower. But this is the flower dipped in liquid nitrogen.
Lutong.
Right? It breaks like ice. It's brittle.
It breaks
Because
like
flowers, like all living things, are made of what? Starts with the letter C. It's made of cells. That's right. It's made of cells. And cells are made of water. They're filled with water. Cells are. They contain a lot of other things, but they have a bunch of water. They're sacks of water. And all that water, when you put in liquid nitrogen, gets frozen. So when you freeze all that water really, really fast, it becomes what? It becomes ice. So that's why I have to use these gloves, because if I put my fingers into the liquid nitrogen, it can be very harmful to me. Maybe this will happen to my fingers. It will break like the flower did. Okay, so that is what happens to living things when you put them in liquid nitrogen. For our next experiment, my mover nut will help me put something else into our container. We'll put balloons. Lobo naman yung lalagyan. Right, so ilang lobo kaya yung kasya dito sa ating container? How many balloons you think can we fit in? One. You think we could fit in 5? Maybe not. Maybe. Let's see. Maybe with the help of liquid nitrogen, we could fit in lots. So let me just put some liquid nitrogen into my balloon. Okay. And maybe, I don't know, maybe you could fit in a second one. Okay. How many balloons so far? Ilan na yung nalagay natin? 2. Okay. You think we could fit in another one? You think? Okay. Maybe we could fit in another one. Saan napunta yung mga balloon? Ilan na so far? 3. Okay. May butas ba? Patingin niyo, may butas ba? May butas kaya. Is there a hole? No, none, right? So we're able to fit in. Ilan na to? We're able to fit in a 4th balloon. There we go.
How many balloons?
What happened to the balloon?
Maybe we could put in one more balloon, a 5th balloon, right? So now we have 5.
Nag-aayos yung kamay niya. Nag-aayos yung kamay niya.
Into my container. What do you think happened to the balloons? Why was I able to fit how many balloons inside? 5. Why was I able to fit 5 balloons? Are the balloons the same size, or did they change in size? They changed in size, right? In what way did they change in size? Did they stay the same size, or did they become smaller? So the guess is smaller. Let's see. I'll put in one balloon out first. That's my first balloon. As you can see, it was small inside the container. And when I put it out, it returns to being big again. Tumalaki siya. That's because balloons have what inside of them? They have air. And the air, in this temperature, pushes the rubber of the balloon and makes the balloon the size that it is. But when you put that air in really, really cold temperatures, what happens to the air? Do you think the air is still big? Or do you think the air will become small? Imagine yourselves in a really cold room. When you're in a really cold room, what do you do? Do you spread out? Magkalayo ba kayo? Or do you huddle close to each other for warmth?
What happened to the balloon?
What do you do when it's so cold? And you don't have a
happened to the
blanket?
balloon? It grows
You
big
huddle each
again.
other close for warmth, right? And that is the same with the gases inside your balloon. There's a sobrang lamig sa loob. The gases don't have enough energy. They don't move far away from each other. And they move slow and close. Because sobrang lamig. So the rubber shrinks back to the original size of the rubber. But now we put it outside. And now the gases inside my balloon will go back to the same temperature as the room, and it will start to become bigger again. Pag ilang balloon na ito yung nilabas natin? How many balloons so far have been out? 3. That means we have how many more inside? We still have 2 more. This was the second balloon we put in there. Right, you can see it was shrunk to a very small size inside the very cold container. And now we have one more balloon, and you can see it's very small in there, and then if you put it out, it becomes very large. There, you wait for this balloon with its weird shape already to become its original inflated size. Okay? So that is what happened to the balloon inside. What happened to them? They shrunk, that's correct. They became smaller. Because that is one effect of our cold temperature, right? When it's really, really cold, we get the gases to compress. Okay. Now let me put more of my very, very cold liquid nitrogen here, and let's now mix it with something very, very hot. And so I have here with me kumukulong tubig. So very, very hot. So when water is very, very hot, what happens to the water?
Boils.
What happens to the water when it's very hot? It boils, right? Boiling is what we call evaporation. The liquid goes from being a liquid to being a gas. And now if you mix it with something very cold things create the opposite of evaporation. It's called condensation, not condensado, that's different. Condensation, right? Condensation is when it's so cold, you form cloud particles, right? So just think about this. Very hot, it creates evaporation from liquid to gas. Very cold, from gas to clouds. Condensation. Now let's mix them together. I'm going to mix something very hot and very cold, really, really fast. And this is what we get.
Whoa! What happened, Daddy?
No kidding, I'm just hiding. This is not the kind of show. I'm gonna go around and I'm gonna please please stay in your seats. Everyone stay in your seats. I'm not gonna come near you if you are standing up. Please stay in your seats and no touching the container. Because again, I'm the only one wearing the very special gloves. None of you have it, so none of you can touch it, but you can still feel the clouds that we made. There you go. There you go. Really cool, really cool. Let's take some more clouds here. And that's all because of the really hot water and the really cold liquid nitrogen mixing together, speeding up the process of evaporation and condensation. So we have lots of evaporation, lots of liquid to gas, and then lots of condensation. Lots of gas to cloud particles. There you go. And that's why we were able to create a really tall column of clouds. Okay, did you find that really cool? I found that really cool. I was surprised at the height of that. It was so high, higher than expected. And I hope that in these experiments, you learn something new. You realize that science is learned by trial and error, and sometimes it can be messy. And you just have to be careful, and you have to do the proper equipment in the correct place. But with this messiness, you can learn a lot of things. Almost like you're playing with nature, and because of that, you learn more about it. I would like to thank you very much for watching us. We hope you enjoyed it, and we hope you learned a few new things about the very cool science of the very cold things. Thank you very much. Once again, this is